Hello my dear students, how are you all? Welcome to part 2 of differential equation. Okay, we have done the part 1 where we talked about basics of it. In today's session we'll talk about application of variable separable method. Okay, we'll solve questions on this method which is very useful to solve any question in differential equation, and we'll talk about homogeneous differential equation. When can we call a function homogeneous? Okay, so today is day 43 of the series 60 out of 60 in KCET mathematics in 100 days. I hope you're working hard. I hope you are doing a very good amount of work, okay, to keep up with the sessions. Okay, so do not just watch the sessions, bacha, please solve the questions at the same time. Okay, so in the session today we'll talk about just the topics that I said: homogeneous functions, homogeneous differential equation, and the application of variable separable method. Okay, so I hope you are prepared. If you need to take a break, please take a break, then you start the video. But once you start the video, make sure that you complete it in one shot. Okay, please learn on the concept in one shot. Okay, have some water and then okay, come back with me, learn the concepts and do the solutions, okay, of the question. Okay, now moving on to the first thing that we have to discuss is what we have to come and learn the variable separable method. So I've tried to explain in the simplest way possible. Okay, I've written it as well over here so that you can understand it in a point by point. Okay, let's see what is the first thing. Methods of solving first order derivative, okay, or first degree differential equation. When is it? Using what method we are learning today? Variable separable method. Okay, chaliye. So we can call, what is the meaning of first order? Okay, first order means the differential is coming only once, means we will be only integrating once. We will not be dealing today with any question, any problem where you will have second order derivative. Okay, for second order derivative, to find the solution of the equation, okay, to find the equation, what you have to do? You have to integrate 2 times, right? You have to do integration of 2 times, but in this case we'll talk about only first order derivative. Okay, first order derivative. Okay, again the degree is also taken as first, means 1. Okay, chaliye. So moving on to this, you can see directly, very simple. First order derivative is there, degree is also 1 because the power of the derivative is what? 1. Okay, now differential equation with variable separable method. Okay, how can we see this? So what we do actually in the given function that we have, okay, we try to put the x variables at one side like this. Please check. So fx dx and gy dy, and then what we do? We integrate on both sides. Then what we do? We integrate on both sides. This is easy to do, right? So if you apply integration, you're going to get a function in terms of x here, in terms of y here. That's what we do. So we'll see in multiple questions. Let me read it for you. A first order, first degree differential equation of the form. First order because first derivative, first degree because the power is what? 1. Okay, function of fxy. Okay, function of fxy. From there we'll separate the x terms at one side and y terms on one side of the equal to. Okay, and then we'll have a result like this. We'll have a result like this. What is the c? This is the constant of integration. Okay, again one more thing, since you might have this question, sir, I have integration over here and over here, why not write 2 times c1 and c2? You can do that, but ultimately you can bring this c1 over here and they'll make again a different constant. That's why you don't have to write all the time c1 c2, just write it as c. That's enough. That's enough. Okay, so you write only one variable, only one constant c, like that. Okay, chaliye, this is what I said. Same thing I've written here, I've shown it over here like that. Chaliye, moving on. That's what it is, bacha. Nothing much is there in variable separable method. This is it. Once we solve the questions, no, you'll understand it very simply. Chaliye. So differential equations reducible. Sometime what will happen? No, the given differential equation will not be directly useful for you if you used to consider variable separable method. So what you do in that case, you have to use some substitution. You have to use some substitution. What you can substitute like this? So instead of writing ax plus by plus c, you can write simply that as t. Okay, and find the derivative of t using that. So and then you will use that in the equation. We'll see that, no problem. Okay, sometimes differential equations of the first order, first degree cannot be solved directly by variable separation, but to some substitution. This is what I said. By some substitution, this is reduced to a simpler form which can be easily solved, and then we can substitute it back to get the answer in original set of variables. Is it okay? Very simple. This is how we have dealt with all the substitution questions, right? Not much is there in this. Chaliye. See, this is the function here was written in terms of ax plus by plus c. Difficult to separate the variable over here, so why not write one variable f of t, and if you just writing that f of t and keep this as it is, it will not be possible to solve it. You have to change this part as well. You have to find the dy by dx value from here. Can you not find it? Check please. If you differentiate it, how much you gonna get? You're going to get a here, you're going to get b times of dy by dx plus 0 for a constant, and this will be what, bacha? Dt by dx, right? So what you can do, take a on that side, take b on that side, okay, and you'll have to keep this as a subject, dy by dx. You'll get that value, substitute it in this place. You'll have the differential equation that you have to integrate using what method? Variable separable method. That will be easier than solving this. You'll see in the questions. Chali. Now, first problem. This is not based upon substitution. This is a simple problem. So, what is it given? X plus 1 dy by dx. Is it first order, first degree? Of course, sir. First derivative, so first order. Power is 1 of the derivative, so first degree. Okay, how can we solve it? Variable separable method will apply. X on one side, y on one side. Try to keep dy, because integral, if you remember, dy is always in the numerator, right? Even if you are integrating a fractional form of integration, even if the rational is there or something else is there, okay, 1 upon a square plus x square, anything is there, you will always have the dy or dx in the numerator. So simply you have to take dx on that side. Please have a look. Okay, please have a look, bacha. So this will be given by dy upon not x, right? I want the y value over here. I want the y value over here. Okay, and I can write this as dx. I'm taking dx over here, bacha. Okay, dx. What is there already? 2x is already there, sir. Have to bring x plus 1 on this side. Will come as denominator because it was multiplied on the other side. Okay, now I can integrate. Yes or no? Yes. Okay, because it is all separated. Please check y, x, x. Okay, now how will you solve it? So this part is so very simply we can solve, but let me keep it at the same time. We'll integrate. I can take 2 common outside and write it as x plus 1 minus 1 upon x plus 1. Yes, I can separate this. So I'm going to get what? Dy by y equals to 2 times. I can write this integration as 1 minus x plus 1. I know you know that by now. X plus 1 by x plus 1 will be 1, and 1 minus 1 upon x plus 1 will be like this. Okay, so if you integrate this, what are you going to get, bacha? This will be ln y. Okay, and this will be what? Tell me. This will be 2 times of x, because you're integrating with respect to what variable? X, sir, minus ln x plus 1. Okay, this is your answer. This is your answer. Okay, so I'll write it over here. Either write ln or log, your choice. So log of, always modulus will come, right? Log doesn't work on negative value of x. We know that already. No problem. X plus, sorry, not plus, there's a minus sign. X minus log of x plus 1 in the mod, like this. This is my final answer. Simple question or not? Very, very simple question. Okay, so whether you want the answer in terms of ln or log, your choice. You can take ln, this is more standard. We always consider natural log. This is with the base 10 or any other variable base, but we standardly take what? With the natural log only. Okay, but sometimes you will find the answer written in terms of log also, so you don't get confused. Same is there. Okay, now moving on to next problem. Sine inverse dy by dx plus equals to x plus y. Okay, is it first order differential, sir? Yes. Check the differentiation. How many times is coming? 1 degree is also 1. A very good question. We'll have to use some substitution over here, so please pay attention. I can write this. I can take this sign over here, and this will become what? It will become dy by dx equals to sine of x plus y. Correct? Now do one thing. Take x plus y, bacha, as variable t, sir. Same thing what we did in the question, that in the statement where we learnt ax plus by plus c equals to t we took. Same thing I'm doing here. If I differentiate, I'll get 1 for the x. For what I'm going to get for y? dy by dx. For this I'm going to get what? For t? dt by dx. Simple, sir. I want to find value of what? dy by dx, so that I can substitute. Bring 1 on this side. Okay, now I'm gonna put all of these values in my differential equation. Okay, this one. So if I do that, I'm gonna get what? Please check. I'm gonna get this as dy by dx will become what? dt by dx minus 1, This will become what? Sin t bacha. Sin t. Yes or no? Now bring 1 on that side. What I'll have? I'll have dt by dx equals to 1 plus sin t, sir. Sir, you said dt will be always in the numerator. Yes, it will be always in the numerator. Please use the what method? Variable separable method. So I'm going to write it over here as dt upon 1 plus sin t. Sir, no formula for this integration, sir. We have not learnt it, sir. No problem. Do not worry about it. Apply the integration now. We'll do it later. We have to just do some transformation. You'll see it will become very, very simple. Okay. Rationalize it. Why rationalizing it? Because if you do that, you're going to get 1 minus sine square. That will be a identity. Something will come out of it. Okay. Just have a look. So I'll write it as 1 minus sine t multiplied to both numerator and denominator. Over here I'll get what? 1 minus sine square t. Do not ask or do not have this confusion. How come, sir? I'll explain you anyway, but you should not have this doubt. Okay, you're a student of KCET. You should not have this doubt. Please think. If you're rationalizing it, you have to rationalize with what? 1 minus sine t. So this will be in numerator. Same you multiply in denominator. What are you going to get? A plus b, a minus b. What is the answer? A square minus b square. So 1 square is 1, b square is sine square. So as the thing I've written over here. Okay, same thing I've written over here. Chaliye. So I can simplify this further. Okay, 1 minus sine t dt is there, sir, and this will become what, sir? Cos square t equals to integral of dx. Okay, now let me write it over here. Okay, I'll write the same thing over here again just to avoid any confusion. 1 minus sine t was there upon cos square t dt equals to integral of dx. Please have a look. Same thing is written over here, there also. Now I can just separate the numerator, making 2 fractions. So 1 by cos square t, what will that become, bacha? Simply sec square t. Okay, I hope you are able to understand that. I am going to write it directly. Okay, write it as sec square t, sir. Okay, now sin t by cos square t. Sin t by cos square t. So out of cos square I'm going to take 1 cos, and sin by cos I'll write it as tan t. I still have 1 cos left in where? In the denominator. That will become 1 by cos. So sec t whole thing with, sir, dt equals to integral of dx. Now question is done. Can you see that? Sec square t because 1 upon cos square, and sin by cos will become tan. Another cos is there because of cos square. You'll get it as 1 by cos, which is sec or secant t. Chaliye. Now integration of sec square is what, bacha? Tan t, sir. Integration of tan t sec t is what, bacha? Minus sec t, sir, equals to what, bacha? X plus c. Put back the value of t. What was it? X plus y. So tan of x plus y minus secant of x plus y equals to x plus c. This is my answer. I thought I'll need more space, but I did not. Yes, I took x plus y as t, no? Okay. Yes, please have a look. Please have a look. I hope this is visible. Okay, simple question. Now what about this, sir? Solve the differential equation x plus y the whole square dy by dx equals to 1. Okay, so I have to use what, bacha? I have to use the substitution. Let's use v here. X plus y equals to v here. If I do that, differentiate, excuse me, yes, simple. Put it back. First you have to find a value dy by dx, sorry, dy by dx. So it will become dv by dx minus 1. No confusion over here. d by dx minus 1. Now put it back. Over here x plus y will become what? V. So v squared dy by dx is what? Please check. Dv by dx minus 1 equals to 1. Correct? Now if I expand this, I'm gonna get what? Please check. I'm gonna get v square dv by dx minus v square. Okay, I don't have to do that. Correct, no? I can just take it on the other side. I can do it like this also, but I can just take it on the other side. d by dx minus 1 equals to 1 upon v square. This is also okay. Now bring the 1 on the side. I can write dv by dx equals to 1 upon v square plus 1. What is that? 1 plus v square upon v square. So dv by dx. Bring the v on one side, variable separable method. Okay, so I'll get what? V square. Okay, so v square dv upon 1 plus v square equals to dx. Okay, chali, this is all right. So next, have a look. V square 1 plus v square dv equals to, what is it? Dx, right? Yes, dx. Now I can write it like this. If you can see, I am applying the integration now. So I can write it like this: 1 plus v square minus 1, no? Minus 1. I'm adding 1 and removing 1 as well. So upon 1 plus v square dv equals to integral of dx. So this will become what, bacha? 1 minus 1 upon 1 plus v square dv integral of dx. Okay, what is the integration of this? For 1 I'll have simply v, and for 1 upon v square I'll have what? Please check. 1 upon 1 plus v square, 1 upon a square plus x square, tan inverse of x. So tan inverse of v equals to x plus c. Okay, what is v value? V value is x plus y. So I can write it here: x plus y minus tan inverse of, what is it? X plus y plus x plus c. Okay, now bring this over here. You're gonna get what? Bring hold of this over there. You're gonna get what? Please check. You're gonna get so x will cancel each other. You're gonna get what? 1 second. Have I missed something? No. Okay, chaliye. So I'll get what? Tan inverse of x plus y minus y equals to c. Okay, so now next condition is homogeneous function. When can we call a given function homogeneous? We have learnt about the word homogeneous. Okay, I think first thing you have learnt this word in chemistry grade, I don't remember, 10th maybe. Okay, so homogeneous function will be similar. Okay, as the name suggests, uniformity. Homogeneous means what? Uniformity. Whenever the degree is same, means whatever is the degree, whether it is 2, 3, 1, the degree of all the terms in the function, okay, each term should be always the same. If that is the case, then I can say what? The given function is homogeneous. Please have a look. So there's a way to test it. We can introduce the variable with a constant. So instead of writing as x, I can write it as lambda x. Why, sir? Because if you're having a power, it will become again, let's say power is 2, so lambda square will become. So you can this can help you understand the degree. So please check. Lambda power n is coming. It means the degree is what? N. Okay, the degree is n. So why I'm saying this? You can just simply write the variable just to test it out with the constant k or lambda, anything. Whatever the power of lambda, the variable, the constant that you introduce will come as, that'll be your degree. Okay, so homogeneous function will always have same degree. If I read this, in other words, a function f of x comma y in x and y is said to be homogeneous function of degree n if the degree of each term is n. Degree of each term is n. Why we are learning this? Because next we are going to use what? This concept in homogeneous differential equation. Okay, chaliye. For example, check here, first one, what's the degree, bacha? What's the power total sum? X cube 3. Over here, sir, only 2 is there. No, sir. Add all the variables power. 2 and there is 1 over here. So 2 plus 1, 3. Here y cube, again 3. If you want, you can just check. Put x as lambda x and y as lambda y. Lambda cube x cube. 2 lambda square lambda y. What is it going to be, bacha? okay, 2 lambda square x square. This is best here, 2 lambda square x square, and this will become what? Lambda cube y cube. So if you check, I can take lambda cube common, and then I'll have what? I'll have x cube plus 2x square y plus, so if you take this common, no, lambda cube over here, please check, you'll have x cube over here, the first term. Over here you'll get what? 2x square y plus y cube. And what is this term? Same thing. It means lambda cube times f of x comma y, f of x comma y. Alright, so this is one way to check it. Just introduce the variable with a constant. Now this equation, if you check here, this is a having what? Please check, this will get cancelled, no? Lambda square, this is not lambda 2. All of this is square, okay? Yeah. All of this is square. Now this is, so is like this only. 2 lambda into lambda will become lambda square. So lambda square will get cancelled, means what is the degree? 0, sir. Means if you want to check, if you want a reason for it, please have a look. Here power 2, here power 2, but also denominator has power 2. Means the degree will be what? I'm not saying that x square will get cancelled. I'm saying that the degree will be what? The net degree will be 0. Okay? That's why the degree of the function is how much? Is given as 0. Given as 0. How come, sir? If you want, I can show you again. So what is the function given? X square minus y square 2xy. Have a look. Degree here 2. Degree here 2. Same thing over here, 1 and 1, so 2. Divide them. What's the degree? Again, sir, 1 is there. No, 0. You'll see. So the effect will be cancelled. The variables effect will be cancelled. If you want, put the x and y as lambda x. So lambda x the whole square minus lambda y the whole square upon 2x lambda and 2y lambda. What I have lambda square times x square plus y square is common in the numerator. Over here also I have what? Lambda square. What is it, picture? 2xy. I can cancel this and this. What I get? Lambda power nothing is there. Okay, so just constant is there. No, so lambda power 0. What is it? Lambda power 0, no sir, because constant is there. Lambda power 0. And what is this going to be? F of x comma y only. If this was f of x comma y, then what is this thing? Same thing, no? So f of x comma y. So what is the degree over here? Please check. Degree is 0. Okay, so this is going to be a homogeneous function of what degree? Of degree 0. We'll use this. That's why I'm giving you this. Okay, for example, I write it like this: y by x. What's the degree? 1. Y is also 1, x is also 1. Okay, it's not a polynomial. I'm not saying it's a polynomial. Don't get into that. Over here, the degree is 1. Okay, chali. If somebody is thinking that way, no, do not go in that path. Over here, the net degree of the variable is what? 0, because y to power 1 and x to power 1, so effect will be cancelled. So differential equation of the form dy by dx, homogeneous differential equation. So obviously a equation which is differential equation which is formed with only homogeneous function. Only homogeneous function, sir? No, only the RHS part. Means either this should be 0, the RHS should be either 0. I should have a function which of what degree? Of degree 0. Means we can keep always RHS to be 0, or whatever the function is there, that should have a degree of what? It should be a homogeneous function of degree 0. So basically what they're trying to say, this function that is written over there, f of x comma y, is a homogeneous function of degree 0. This has to be always true, of degree 0. Then we can say what? The given differential equation is what? Homogeneous differential equation. Okay, now what are the steps to solve these differential equations? Question is, what are the steps to solve these differential equations? So step number 1, okay, identify whether this is the differential equation or not. How to test it? The RHS should be what? A homogeneous differential function, okay, with degree 0. It should be a homogeneous function with degree 0. Okay, next what? Assume y to be a variable with the help of vx. Okay, now differentiate y to get v plus x dv by dx. How come this is true, sir? Product rule. Applying product rule in vx will give me what? V as it is, and x will be kept. Okay, for x you're gonna do the differentiation, you're gonna get 1, and x you keep as it is, dv by dx you're gonna get. Okay, in the given differential equation. All right, separate the variable. This you know, this all steps you know. Variable separable method, integration, and at the last what are you gonna do? Substitute back the value. So you took y as vx, no, so v is an additional variable, so y equals to vx. What's the new variable? V. So find the value of v from here. V will be y by x. Bring this x over here, and substitute wherever you get v after solving it, substitute it back with y by x. You have to. Okay, chaliye, shall we move on to the next question? Okay, so I have kept that restriction till this point only. We'll do the questions on this category, and in the next session we'll talk about linear differential equations. Okay, and we'll solve questions. So I'll try to do 2 more sessions in differential equation, one on linear differential equation, and do some questions on that, and I'll do 1 more session just for question practice. When in the live session I saw a lot of comments in that, sir, more questions in KCET series. I am giving more questions, but if you are not satisfied, I'll give you more and more practice sessions, don't worry. Okay, chaliye. So I cannot give a lot of it right now because I have to complete the portions as well. Okay, so I have PU2, I think I have 4 chapters left. So 4 chapters I have to complete, then I have to start PU1 also. But I'll try to give at least 1 additional session wherever it is required for practice. I hope this is enough. Please let me know in the comment section. Just thank you, sir. Let me know. It'll motivate me that what I'm doing is right. Okay, bacha? Chali. So that the differential equation is homogeneous and then solve it. Kar lenge. Okay, let's do it. How can we solve it? Let's do one thing. Divide everything by x dx. Everything by x dx. Please check. It's going to become what? It will become dy by dx. This will become minus y by x. Okay. Now over here also, please check. By x, and dx will be cancelled. Okay. Continue with the step. Okay, this will become what, bacha? I am taking this x inside. It is outside the root. X is outside the root. I am taking it inside. It will become x square. Yes, please have a look. Now tell me, what is the degree over here? It's 0 only, right? Yes or no? Y square x square. Okay, the degree power is same. Over here also yx power is same. Okay, so it's 0 only. Now what I'm going to do, next step is what? After getting this homogeneous differential function form, we're going to write the substitution. What is it, sir? Y equals to Vx. Differentiate it. So dy by dx equals to V plus x dv by dx. Okay, yes, use it in this condition. So v plus x dv by dx minus, this is for just dy by dx. What is y by x? Please check from here. It will be simply v. If you bring x here, y by x will be simply v. So minus v equals to the RHS 1 plus v square. Y by x is v, right? That's why. Now cancel this and this. What are you going to get, bacha? We'll have dv upon 1 plus v square. Okay, this will be dx upon x. Correct? I can bring the dx over here and bring x down. So integrate this now. What is this going to be? This is standard. Okay, so this will be both are the standard result. Log, what is it? Log v plus root under 1 plus v square, correct, equals to, what is it, log x, and constant I'll get, right? So why don't write it like log only, log c. Why like that, sir? Because log a plus log b, I can use the formula for that reason. Okay, so now apply the log over here. Log formula will become log xc. Okay, log v plus 1 plus v square. I'm taking out, see, both sides are log are there. I can take exponential function on both sides and log will be cancelled. Okay, so I can ignore the log and write it directly like this, v plus, okay, modulus will make what, positive negative, so plus minus xc. Log operates only on the positive side. Okay, so for that reason plus minus will come. Okay, we are taking out log. So now I'll write the value of v back because this is the answer, but I cannot keep the answer in the v because that's a variable that I assumed. I have to put it back. So how will that look like? Please check. I'm getting v root under 1 plus v square equals to plus minus xc. So what I can do, I'll write v as y by x plus, in here also, okay, 1 plus y by x the whole square, 1 plus y square by x square equals to plus minus xc. Take the LCM. So first of all, I'm going to take this inside the root. We'll get what? x square plus y square equals to plus minus xc. Okay, I can take this x square outside. It will become what? Y by x plus root under x square plus y square upon x plus minus xc. Take the LCM bacha. Y plus x square plus y square equals to plus minus xc. Okay, what I'm going to get? Y plus x square plus y square equals to x square c. Okay, or I can write a constant k and ignore the plus minus sign as well. So please check your answer. Okay, this is your answer. I don't think there's an option involved here. No option. So this is the final answer, bacha. This is your final answer. So have a look. Okay, so if you have solved it, you should get this answer. Please have a look. I hope everything is visible. Simple problem. Okay, but just we have to use that. First, you have to get in the form of what? Homogeneous differential equation. We got it here. This one. Then we have to use the substitution. Use the variable separable method to do the integration. Okay, and then substitute back the variable v as y by x, getting the result as y plus root of x square plus y square equals to x square plus k. I know some of you must have got stuck at this place. So taking log of c. Yes, you got stuck over here. It's okay. Why I'm taking log of c? Because I have log everywhere. So I can ignore the log by taking exponential function on both the sides. Okay. Chaliye. Now question number 5. Solve the differential equation dy by dx minus y by x plus cos x y by x equal to 0. Okay, very good question. They're asking us to find what? Particular solution, because they have given x and y value. X is 1 and y is 0. So first we have to find that solution, then put the x and y value, okay, to get the what? The constant value c, and then we'll put back the c value to get what? Particular solution. I talked about this in the previous session. So let's have a look. Okay, so what I can do first, I can take it as, okay, the degree, okay, let's just take this part first. So y equals to xv dy by dx equals to v plus x dv by dx. Okay, substitute back. For dy by dx, what I'm going to get? V plus x dv by dx. For y by x, what I'm going to get? Simply v. So minus v plus cosec v equals to 0. Yes, v and v cancelled. Okay, I'll bring the cosec v on this side. I'm going to get what? X dv by dx equals to minus cosec v. Okay, dv is here, so I'm going to bring this cosec v over here. I'm going to get what? dv by cosec v equals to dx by x. There's a minus sign. Integrate now. Okay, I can write cosec as what? Sin v dv minus dx by x. How much is that, bacha? Sin integration is minus cos v. What will this be? Minus, how much is that? Minus minus log x and plus constant c. I can take the minus sign out. Okay, this will become minus, doesn't matter. I'll get what? Cos v equals to log x. Okay, plus I can write a constant k, no problem. Minus c can become what? A constant k. Okay, now I'm going to use the value of x and y. First of all, I have to put the value of v first. Okay, so I have the relation as cos v equals to log of x plus k. How come k, sir? If you have this doubt, see, I am getting as minus c. Why minus c? Because I'm cancelling this minus, no? So this will also become minus, plus will become minus. So I'm writing minus c as k. I'm writing minus c as k. I can take another constant. No, minus 2 is also a constant. If 2 is a constant, minus 2 is also a constant. That's why I'm taking it as k. Now what is v value? Y by x. Put it here. Cos of y by x equals to log of x plus k. X and y value they have given. X is 1, y is 0. So put it here. Cos of 0 by 1 plus log of 1 plus k. Yes, how much is that, bacha? This is 1, this is what? 0 plus k. How much is k, bacha? K is simply 1, sir. K is simply 1. Log 1 is 0 and cos 0 is what? 1. So k is 1 means I can write it this as cos of y by x, okay, plus log x plus k. I'll write it as 1. I can write 1 as, if you remember, log of e. Can I do that? ln is what? 1, no? Log with the base e to e is what? 1. So log a plus b will become what? Check here, log a plus b. Log a plus log b. Log of x into e. What is the answer? Answer is going to be cos of y by x becomes e into x. It's not e power x. It is e into x. E into x. Okay, simple enough. All right, chaliye, have a look from the beginning. What I've done, y by x as v, then the differentiation of y with x, then substituted back I found the new differential equation, use the variable separable method, did the integration, substituted back the value of the variable v in terms of y and x, use the condition for x and y given to find the constant value, and this is my particular solution. This is my what? Particular solution. Okay. Moving on. Question number 6. Solve the differential equation dy by dx x minus 1 equals to 2xy. And I have done a similar question like this. I think first one was the same, no? But let me solve it anyway again. How will I solve it? Bring it over here. dy upon y equals to 2x upon x minus 1 dx. Okay. Integration dy upon y equals to what, bacha? Please check. Can I write it as 2 outside, x minus 1 plus 1 upon x minus 1 dx. Correct? 2 is a constant, I am taking it outside. X minus 1 because denominator is the same. X minus 1 because denominator is the same. So write it like this. So it will become what? 2 times of integration 1 plus 1 upon x minus 1 whole thing with dx. Okay, how much is that? This is simply ln y or log y, 2 times of what? 2 times of x plus ln x minus 1. This is my answer. Plus c will come. Integration is there, no? So plus c will come. ln y 2 times of x plus ln x minus 1 plus c. Final answer. Okay, yes, simple enough, right? Question number 7. Solve the differential equation dy by dx 5 e power x 5 power 4. Okay, this I think you can solve without even using a pen and paper. So dy by y power 4, I'll keep the 5 constant outside, and ex dx, integrate. Okay, how much is that? 5 y minus 4 plus 1 minus 4 plus 1, this will remain as it is, ex plus c. What is the answer? 5 y power minus 3 minus 3, simplify this, minus 5 by 3 y cube, okay, equals to e power x plus c. Final answer. Minus 5 by 3 y cube equals to e power x plus c. Yes, very simple question. Okay, chaliye. Solve the differential equations dy by dx equals to y times of 1 plus x, x times of y minus 1. Okay, so this will be your last question of the day. I'm promising I'm gonna come up with more questions. Please let me know if you have the requirement. Anything you want to ask me, you can always ask in live session, but you can also ask in the comment section of our videos. Okay, so please let me know. Please fill it with your queries. I'll try to answer. Okay, and I'll get back with your solutions for your queries. Okay, so solve the differential equation dy by dx equals to y times of 1 plus x times of y minus 1. Simple, we can do what? Variable separable method. Let's see if it works. Okay, so I need the dy is over here, so I need all the y terms on this side. So y minus 1 will go in the numerator, this will go in the numerator, and this y will come here. So upon y, I'll take dx over here, this dx I'm taking over here. Okay, and 1 plus x is already there. I'm going to take this. Okay, this x is also over here only, so no problem. Divide it. What I'm gonna get 1 minus 1 by y dy whole thing equals to again 1 by x plus 1 dx. Rest is what? Integral. How much is that, bacha? Please check. This will be y minus ln y. Okay, for 1 I have y, for 1 by y I have ln y, I have 1 ln y. For yes, I'll have ln x. Okay, and for this I will have what, bacha? Plus x plus c. I'll bring everything on one side, so I'll get what? ln x plus ln y plus x minus y equals to c. Okay, yes. Sir, how come c is on the right side, same side? No, don't worry, then write it like this. Plus c equals to 0. I can bring the c over there. It will become minus c and write it as another constant. No problem. Okay. If you are, because some students have this confusion. Do not worry about the constant that much. Okay. All right. Only if the boundary condition is given in the question, then only the constant will become very, very useful. ln x plus ln y will become what? Will be ln of x plus y. Sorry, ln of x into y. ln a plus ln b. ln of ab. Okay, so this will be mod. Log will always operate on positive values. So ln xy plus x minus y equals to some constant minus c is there. I can write it as a constant k. Final answer, sir. Very simple question. Okay, please have a look. We have to just take care while taking putting in the form of variable separable. While using variable separable, we have to make sure that we are not making any mistake, and then rest of the things are very, very simple. Okay, so have a look. Yes, so this is it, bacha, for this session number 43. Okay, that's all. Next session we'll talk about, we have one more topic left in this to do, which is linear differential equation. We'll learn it in the next session. We'll solve questions on the next session. Then I'll keep a practice session for it. I cannot keep more than that. If I have to, I'll keep it once I complete the session. So do not worry about that. Once I complete the PU2 portions, maybe for 1 or 2 days, I'll do some practice questions for all the topics. Okay. For now, this is it. I hope you're working hard. Okay, you need to. The time is coming closer and closer, so I hope you are solving all the questions that you can. I'll see you in the next question. Okay, and the next series. So I'll come up with the question series. Okay, I'll try to let me finish the chapter, then I'll come up with the series for the questions. And with that, I would like to end the session. Keep working hard, keep smiling. I'll see you in the next session. Take care. Bye bye.